Hey guys, in this video I'm going to discuss the conditional probability. So the conditional probability is a bit different than what we've been learning because the denominator will no longer be the total. So if you've seen my past videos, you would understand what I mean by total. So first I'm going to start with the formula and then I'm going to demonstrate what I mean by example. So the probability of A given B is equal to the probability of A and B over the probability of B. So this here must be the denominator, always. This here is the word given. So let me change that. So given. Now, sometimes given can also be replaced with two other words, if and out of. So given, if, and out of are all the same meaning when it comes to probability. This part here, I'm going to change this highlighter. This part here never ever is the independent formula that we learned in our last video. In other words, you're going to have to know this intersection. You can find the intersection whether it's in a box, a table. Remember, we went either across the table and down the column. So we'll put that number in here, and then it's going to be out of a conditional probability. So let me jump right into an example, and I think everything will be clear. We asked 60 random people whether they identified as a male or as a female, and whether they were a smoker or a non-smoker. So this is this table, and so I have 40 males, I have 20 females, I have 11 people who are smokers, and I have 49 people who are non-smokers, and there's a total of 60. So let me get my highlighter back. So this is our total. In this problem, I say, what is the probability that a person chosen at random is a male? So just remind yourself that you have to use notation. So the probability of a male, well, that's just going to be 40 out of 60, or 2/3, but we're going to keep it as 40 out of 60. So that was very simple. In the next problem, I ask, what is the probability that a person chosen at random is a non-smoker? So this is my non-smokers. So what's the chances that you're going to choose someone that's a non-smoker? So the probability of non-smoker is just going to be 49 out of the total. Now, in both of these examples, we use 60. So we use this number here. We use the total because we don't care if the person was a smoker or a non-smoker. We just wanted them to be a male. And in this case, we didn't care if the person was a male or a female. We just wanted them to be a non-smoker. So it was out of everyone. So in the next problem, this is where conditional probability comes in. We asked 60 random people whether they identified as a male or female. So it's the same question. I just recopied it so we can have it on this page. There's 40 and 20, and then there's 11, and there are 49 for a total of 60. Now this key word here. So let's read it. Given the person is a smoker. That word given, you can replace it with out of the smokers. So how many people smoke? These are my smokers. These are my smokers. So out of those people, so out of 11, what is the probability that the person is a male? So out of these guys right here, what's the chances the person's a male? 7 out of 11. Notice how it's not out of 60. because this is a conditional probability. The condition is that we don't want it out of everybody. We just want it out of the smokers. So it's almost like, hey guys, let's separate into two groups, smokers and non-smokers. Now, if you are a smoker, how many of you are males? 7 out of 11. So let me just show you the notation, okay? So given the person is a smoker, this here, and then I put this way too early, this here, smoker. So this is the given. Given they're a smoker, what's the probability that they're a male? So if you remember, from here, or from here rather, this is my formula. You can always pause the video and go back. So this is going to be male and smoker over smoker. Now, let me get rid of this. I should have left the 11. Okay, so where does male and smoker meet? So here's male, here's smoker. They meet at 7. So that's this guy. And then where does smoker meet? Or what is the probability of smoker? 11. So guys, I'm showing you the short way, but we know that this guy here is the letter P, and that's a probability. We know all probabilities are fractions. So I'm going to show you the correct way of doing it. This is also correct, but the longer way. And then I'm going to show you why it reduces to 7 over 11. The probability of male and smoker is going to be 7 out of 60. The probability of smoker is 11 out of 60. When you're dividing fractions over fractions, you can cross off anything that matches. And that's why this is 7 out of 11. So you can do it this way right here, or you can just say, all right, out of those who are smokers, you can read it as out of those who are smokers, what's the chances the person is a male? So let's try a clean example. What is the probability that a person is a smoker if they are a female? What is the probability that the person is a smoker if is given, they are a female? Given means out of. If they are a female, what's the probability they are a smoker? So what's the probability they're a smoker if they are a female? So how many of them are females? This is my females. So that's 20. Out of those 20, how many of them are smokers? That's your smokers. So it's 4 out of 20. So the conditional probability doesn't look at the total. It says, let's break them up into what I'm interested in and then choose from that group. So that's your conditional probability. If I wanted to do it the long way with the formula, this would be probability of S and F over always over this person right here. Think about your paper being rotated. This guy here is on the bottom. So where is, what's the probability of smoker and female? That's 4 out of 60, which is the total. And then what's the probability of female? 20 out of 60. And then when you reduce those, you get 4 out of 20. Let's see if I have one more example. I was hoping, so we can just try one. That's fine. What's the probability that the person is a non-smoker given they are a male? So that means out of the males, how many of them are non-smokers? So we're going to go to males. Let's go to this table here since it's already done. Out of the 40, how many are non-smokers? 33 out of 40. So we have to just make sure that you identify if it's a given, which in a lot of cases it is. So a given, an if, and out of. Those three words means the probability is conditional. And so that's how we do conditional probability. And this is the formula. And sometimes you could just think about it without a formula and say what makes sense. Okay, so I just wanted to say that this was our last video on learning probability. I'm gonna make 2 more videos on just problem solving all the types of probability questions that we learned in all the videos. So I hope this was helpful. I hope you guys understand what I was just doing. And we're going to be doing a lot of these in our examples.